All right, we got another good one for you tonight. We've got everyone's favorite guest, the renegade scholar himself, Randall Carlson, is back. We're going to talk about our upcoming trip in May, for the most part, for 10 days at Pagosa Springs, Colorado, where we're going to meet with Randall down there and a bunch of people from the show, a bunch of listeners, and we're going to get into some of the things we're going to do during those three to 4 day visits down there. So welcome back again, Randall. Thanks for spending some time to chat with us about this.
Well, thanks for having me back, Graham.
Yeah, it's good to talk to you. So, where do you want to start this off with? I mean, I've been in the Zoom a couple times where you guys are talking about what you plan on doing. I mean, I'm realizing that there's lots to do in Colorado where we're going to be staying at the cabin, and then we can also leave some time open for some of the new stuff that is happening at like Sacred Geometry International and some of the new news that's coming out. I feel like I'm seeing stuff every week or two here that has to do with your research and kind of, vindicating it. So we can maybe save some time for that as well.
Sure. I'm wide open, whatever you want to talk about.
Yeah. Well, let's start with the trip then, and what you kind of envision there for a couple of your day trips.
Well, as you said, the lodge that, is it Alan who has actually procured that? Alan Neal has procured that for us.
Yep, Elk Lake Lodge. Yep.
Elk Lake Lodge. Yeah,
yep.
Okay, thanks. Elk Lake Lodge. Yeah, it's just north of Pagosa Springs, which is in southern Colorado. And a lot of interesting things to do and see around there. So the focus of the field trips would be both archaeological and geological.
Right.
So we're right there just south of us. It would be the northern extent of the Chacoan culture, and we would be visiting some of their places of habitation, some of their sacred locations, some of their observatories, like Chimney Rock, which would be very close to where we would be staying, is two large pinnacle rocks that were used as sighting astronomical motion, and we would go be visiting that place and taking a day trip up to see not only a very unique geological feature, but how it was incorporated into their system of archaeoastronomy and how they used it as a way of mapping the heavens. And there is a ridge there with a kiva on it and what had been at one point a signal tower. And the signal tower would be a place where the people could build a large bonfire that could be seen from a far distance away. And where we would be at would be the northern extent of a whole roughly 10 or 12,000 square mile in extent infrastructure that was built by these people between probably, I would say, 2,500 years ago down to about 800 years ago. And it consists of a whole series of structures such as kivas and complexes of along with outliers and signal towers and straight roadways. And we won't have a chance to get fully down into the extent of it, but we will be seeing some of the northern rim of it there at Chimney Rock and at Mesa Verde. So that would be a big part of what we're doing. Now, Mesa Verde is one of the most extensive collections of cliff dwellings probably is the most extensive collection of cliff dwellings in North America.
Right. That's the one we see all the pictures of all the time. People show the little huts and all that in there. Yeah.
That's exactly right.
Yeah.
Yep.
So that'll be fun to check out.
Yeah.
Oh, yeah. That would be. And so, Canyon of the Ancients is near there, so I think that would be on the list. Number of other things that we could do, just not only. So I like to break things up when we do these excursions and have not only the research and the quest for interesting sites, but also to do things that are fun, such as maybe we could spend a day on the riding up the San Juan River Valley on the Durango, or the Animas River Valley on the Durango-Silverton Railroad, which goes up, and you can see areas from there that you can't see anywhere else unless you hike in. It's a very unique geological channel up there that conveyed huge amounts of glacial meltwater at the end of the last ice age. So there would definitely be some of that as well. And then, I understand that you've got a couple of chefs coming in. Is that true? You've got some people going to be cooking food there? Yeah,
it's going to be catered, yeah. Or I guess Darren's breakfast and lunch anyways, right?
That's right.
Are people still on their own for dinner? So,
people be on their own for dinner, but we'll have breakfast and lunch for them.
Yeah, they're friends of the show too. So they've sort of told us they're going to help out with that, with the menu and taking care of us food wise, which is fantastic.
Which was that? What was that train ride called again?
It's on the Durango Silverton.
Oh yeah, so that looks just beautiful.
There's pictures of it. There's pictures of it on hdtravel.me or also badcomet.com. And if you go to the Elk Lake Lodge, there's a bunch of pictures there, and I think that's the train going along the side there. Yeah.
As soon as my computer boots up here, I'm going to check that out.
Yeah, it looks pretty fantastic. There's also a hot springs at Pagosa Springs I didn't even know about before. That's pretty cool.
Oh yeah, I mean that's where it gets its name from centuries, if not millennia, old sacred springs that were utilized by the Native Americans who inhabited the area for thousands of years. And so those springs are there, and I'm sure we would get some chances to go and immerse ourselves in the springs. They're not. Apparently, are some primitive springs, but I think they're fairly developed. But it's still the water straight out of the ground, the hot water straight out of the ground. It's there right next to the, basically overlooking the San Juan River, which flows through Pagosa Springs.
What about Colorado, as far as we've talked to you in the past a few times, and we talk about the big melt and the meltwater and all that, but it seems to me like most of that happened, or it seems to be the context of that is kind of closer to where we are in Calgary, and then I'm always thinking of it just below. So there's parts where that has carried through, like that meltwater is carried through down through Colorado as well.
Well, no, that would not be direct glacier. Well, yes and no.
Yeah,
it was not meltwater coming off of the great ice sheets. When you're in Calgary, you are under. What's interesting about Calgary, it's right in that zone where the great Laurentide ice sheet met the Cordilleran ice sheet. Now, the Laurentide was the bigger of the two, the one that was kind of centered over Hudson Bay. The Cordilleran was over the Canadian Rockies, and when those ice sheets melted, there was a tremendous amount of meltwater that fed directly off of those.
Yeah.
The area where we're going to be in Colorado was not being fed by those glaciers. There were, however, more extensive glaciers over Colorado and all along the Rocky Mountains during the late Ice Age. So they melted, but I'm assuming also that a lot of the fluvial features were formed by, very intense, prolonged torrential rainfall, because you can see a lot of the evidence of rainfall, all over unglaciated areas. For example, in the Southwest, south of where we would be, down in the deserts of Arizona and New Mexico and Southern California, you can find the work of gigantic water flows. And, of course, these were not being fed directly by the great ice complexes over Canada and northern United States.
Right.
You can also find those in the southeast. All in the southern Appalachians, there are massive boulder-choked channels, with boulders the size of, stacked up that are the size of SUVs. And, they are the product of discrete events that have occurred that are way outsized compared to typical things that we've experienced in modern times. And the dating that I've looked at for the events in the southern Appalachians mostly seem to point to the terminal ice age, again, around that critical Younger Dryas period, from about 11,000 to 13,000 years ago.
So was Colorado under ice back then?
No, not as a whole. There were mountain glaciers.
Right. Okay, but it wasn't like covering that low in the States back then.
Correct.
Okay.
Exactly.
Yeah.
The mountain glaciers were much more extensive.
Right.
During the late Ice Age. But no, it was not under or covered by the great ice sheets that covered pretty much all of Canada and a pretty good chunk of northern United States.
Right, like Dakota, some of Idaho and all that, yeah.
Yeah, northern Idaho was under the ice sheets, northern Washington State, northern Montana, North Dakota, northern Minnesota, northern Wisconsin, all the way down to east, like around the Mississippi.
Yeah.
The ice came as far south as it came. It didn't come as far south in the western states as it did around the central states. Just because the lowland and the topography made it easy for the ice to migrate down south. So some of the earliest ice ages came almost as far south as, like, say, St. Louis. But yeah, so those glaciers, for example, when they melted, you had huge volumes of meltwater coming down the Mississippi River. You had huge volumes coming down the Missouri River. You had tremendous volumes of water coming down the Columbia River. All three of these rivers, and the Ohio River as well, all four of these rivers headed onto the southern margin of the Great Ice Sheet. So when the ice melted, it was feeding water directly into these river valleys. Whereas if you go down to in the area where we're going to be, like by the San Juan River, the Rio Grande River, the Animas River, they were not being fed by the Great Ice Sheets. They were being fed by more extensive mountain glaciers. But I think that the extent of the flooding, like when we go through Durango, we'll see Durango is actually built in a channel that has these massive terrace formations. And, what we're going to do is we will have not only the field trips, but we will do multimedia presentations to show people and exactly, what it is we're looking at, how these features were formed, so that then when we go out in the field, we'll already have some of that background knowledge. So we're going to incorporate both. We'll do like slideshows, possibly videos where we'll show, okay, here's a particular feature, here's an animated clip showing how it formed. Then the next day we'll go out and we'll see features that were formed of those kinds of, That makes it more interesting. I mean, people see this stuff all the time, but they have no framework for understanding what they're looking at.
Yeah.
So that's what we're trying to remedy here. We're trying to teach people to see the world through new eyes and to understand and recognize that there are these tremendous features all around the planet that are the legacy of these tremendous world-changing events.
Yeah.
And out there, Colorado, where we're going to be, is not immune from that. And much of what we'll be looking at will be the consequence of tremendous events.
And then, then we'll be able to just hang out around a fire in the evening, and I think there's so much more than just the geology and the archaeology to talk about too. We had you over at the studio there a few years back, and I'm looking forward to some of those sort of esoteric conversations and stuff like that were just great, and we could do it. It'll be a little warmer down there. Well, mind you, we're here in the summer. It wasn't so bad, but we can light a big old fire.
Oh yeah. Well, we'll have a bonfire and kind of relive what it was like to be on one of the Chacoan people up lighting the signal fires, the bonfires to signal. That's another interesting thing that we could do as a future excursion would be to explore, because where we're going to be is we're going to be on the very northern rim of the Chacoan culture, but it filled the whole San Juan Basin of New Mexico and then spilled over, into Arizona and southern Utah. And there's a whole complex of these ceremonial centers and these outlying sites that are apparently used ceremoniously, and these signal towers, which were dotted around the desert, spaced far enough apart so that you could basically, and the whole complex appeared to be centered on Chaco Canyon. So there was actually a signal tower on the rim of Chaco Canyon. If a bonfire was lit on this prominence, it could be seen for 10 or 12 miles away. And there would be another signal tower over there at these other locations. And when the central signal tower was seen near Chaco Canyon, other bonfires would be lit on top of these other prominences that were these signal towers. And within a matter of probably literally minutes, you could get a whole network covering of these fires that could be seen over an area of 10 or 12,000 square miles. And so when we go to Chimney Rock, that will be one of the northernmost Chacoan outliers that was used not only as an astronomical observatory, utilizing these really unique natural prominences, these natural rocks, pinnacle rocks, that's what I'm trying to say. It was also a signal tower, and you can actually see the remnants of the signal tower. And there are, last time I was there, I think, which was 5 or 6 years ago, you could actually see where the burnt timbers had been up on top of this mountain. So then that particular signal tower could be seen 20 miles to the south. You couldn't see it directly from Chaco Canyon, but you could see one that was 10 or 12 miles north of Chaco Canyon. And then when that bonfire was lit, you could see that fire from Chimney Rock.
Wow. That's like right out of Lord of the Rings. Like that's what they show like in these big fantasy epic movies. That's how they communicate, all these signals like getting spread all the way along.
Sequence, I think it was in Return of the King, wasn't it? Where they were using the signal towers.
Yeah.
Yeah, it's pretty much the same system.
Yeah. So do you know what they were signaling for back then? Like, was that invasion type stuff, or was I wonder if it was or weather? I wonder if it was like for natural stuff or for like just tribal invasion type things.
I don't know.
Yeah.
I would like to know, and I don't think anybody really knows. I don't know.
Well, I'm an Indian, so I have some standing.
Maybe somebody will figure it out in May. Somebody will have an epiphany, and we'll finally get the lowdown on what they were up to.
Yeah.
Smoke signal podcasting.
Yeah.
This is it. We do have a question from the chats.
Okay.
There's a super chat. It came with a donation to the show, so
nice.
It's gonna get cherry picked. Once again, I turn out to be influenced by donations. So here we go. Hi, Randall and Grimerica. I enjoy all your work. A question for Randall, if that's okay. If you look at Göbekli Tepe's vulture stone pillar number 43, the handbags on top, zoom in. There are trees, animals, and humans becoming overcome by a tsunami. I have done a lot of work on my channel triangulating the position of a comet impact in the South Pacific Ocean 10,800 BC, which may have caused this or a similar event congruous with your work, and unifying it with Robert Schoch's CME in 9600 BC, many disasters over many millennia. I've brainstormed narrow approaches where tsunamis would be amplified like Alaska's Litwa Bay and the Gulf of California as a good candidate for mega tsunami launch ramps. Feel free to answer when you have time.
Oh yeah, clearly. What's the name of the individual? Do we have a name?
Pangea Republic. So
okay,
we don't have a real name.
Okay, but that certainly is a good enough name. I like that, Pangea Republic. I think clearly one of the things that we've seen in the last decade or two is the realization that many of the global coastlines have evidence of these massive tsunamis. It sounds interesting. I would not be shocked to find out that there's evidence from 12,800 years ago for an impact into the Pacific Ocean. I think we're just beginning to really figure out how complex this series of catastrophes really was. A lot of the so-called critics who have been, kind of derisively dismissing some of these ideas, they will say things like, well, if it was an impact, it would just be one single event that we would see, and then it would be over. for example, in the mass extinctions of the great megafauna, they were looking for the idea that, well, if it was an impact of something from space, it would be all at once, and the mortality event would have been across the board, and then it would have been over, and it wouldn't have been something that would have, stretched out over 1,000 or even 2,000 years or longer, which apparently it did. But really, when you begin to reconstruct the geomorphic evidence and the paleoclimatic evidence and the proxy evidence, there was a whole series of things that happened. It wasn't one clean event that kicked the Earth out of the Ice Age. And I think that just like, when we look back at the year without a summer, which was the year 1816, this came right during the period called the Maunder Minimum, which was a period of very low solar activity. And it was also coupled with a period of heightened volcanic activity. So you kind of had it coming from both ends. It was kind of a perfect storm in a way. You had a series of volcanic events. I think the first one actually, they don't know where it was. The volcanologists don't know exactly where it was, but it definitely left a signal in the Greenland ice cores and other ice cores that would have happened in 1809. Then there was apparently a couple of others, but then the biggie was Tambora in 1815.
Mm-hmm.
And that particular one really blanketed the Earth's atmosphere with sulfate aerosols, which then created like an insulating reflective blanket that basically reflected a lot of the solar radiation back in space, and it caused cooling. But then that occurred at the same time, basically, as you had this period of low solar activity. Now, it's interesting, there's some work out there that I haven't really had a chance to fully investigate yet. It's very tantalizing and suggestive, which is this, that it seems there may be a correlation between times of low solar activity and heightened volcanic activity. What the correlation would be there, I'm not sure, other than perhaps during a period where there might be several decades of diminished solar activity, there may be enough of a cooling within the lithosphere that it could cause a volcanic reaction. I'm not sure what the explanation would be, if the correlation is spurious or there is actually something there. We certainly do know that during the deglaciation, there was very intense volcanism going on, because I have pictures, photographs of where you can see thick layers of volcanic ash sandwiched in between flood sediments when these gigantic mega floods were going on.
What was the solar activity like then?
Well, it was apparently doing some very strange things from what I've been able to find out. It seems like there was a period of increased solar activity, but then that was causing the warmth. You see, just prior to the onset of the Younger Dryas, you had about a 2 millennium period where the climate of the Earth was undergoing a gentle warming. That warming was consistent with the Milankovitch forces, which is the result of three factors involved in the geometric relationship between the Earth and the Sun. And as those factors change, what happens is it regulates the amount of solar heat that reaches the Earth. In some periods of time, it allows an increase in warmth, particularly in the northern hemisphere, and in other times it's a decrease in warmth. Now, the Milankovitch cycles, or the Milankovitch forces, usually play out over millennia, right? And what we see at the end of the last ice age is consistent with the gradualistic models of Milankovitch warming. This was named after, what was he, Czechoslovakian, I think, mathematician named Milutin Milankovitch. Anyways, what old Milutin found out was that you would have times where the forces would amplify each other, and at other times the forces would cancel each other out. And what I'm talking about here now is, for example, the distance of the Earth from the Sun, having to do with the changing ellipticity of its orbit, the obliquity of the ecliptic, which is in the precession of the equinoxes, the precession of the Earth's axis. These three interacting forces like I said, can amplify the solar effects, or they can dampen the solar effects, right? What we see in the last couple of millennia coming up to the sudden younger Dryas transition is that the climate was warming. And so if you go back 17, 18 to 20,000 years ago, you're in the period called the late glacial maximum. And that was the coldest depths of the last phase of the Ice Age, and it was also the most extensive distribution of the ice sheets. And it was during this time when the Cordilleran and the Laurentide ice sheets coalesced right around Calgary, right? Yep. When the warming began, both ice sheets began to shrink back. And this is most likely the time when the so-called ice-free corridor would have opened up between the two great ice sheets and allowed migratory passage through that corridor. And for a long time, this ice-free corridor was part of the models of the peopling of North America, that the progenitors of the Clovis people came across the Bering Land Bridge. They wouldn't have been able to migrate southward during the peak of the Ice Age because you basically, you get to Alaska and there would have been a giant wall of ice. But after a couple of thousand years of this Milankovitch warming, it apparently opened up enough of a corridor between the two ice sheets that you could have made passage between there. Excuse me. But then what happens is around between 12,800 and 12,900 years ago, there's a sudden change in the global climate. And this is the onset of the Younger Dryas cold period, which lasted for about 1,300 years. From the previous time, which was called the Balling Alarod. There was two back-to-back periods of the Balling and the Alarod, which were these periods of this warming climate, right? And so when the ice sheet started receding, you had the great megafauna were following the receding margin of the ice sheet towards the north in the lower United States area. Likewise, and here's the interesting thing. The recession of the ice was apparently about as fast on its northern rim as it was on its southern, which doesn't seem to make sense. But anyways, right around 12,800 to 12,900 years ago, the sort of more normal gradualistic warming that can be explained suddenly terminated, and within a matter of a year or a couple of years, or maybe far less than a year, there was a major shift in climate, and it basically snapped back into full glacial cold like it had been at 17, 18, 19,000 years ago. And for the next 1,300 years, the melting stopped, the ice sheets began to grow again, and then at 11,600, there was a period of rapid warming. Now, I also failed to mention that around 14,600, according to the most recent dates, there was a huge spike of meltwater into the global oceans. Now, I think we have to look at some of the dating during those periods with a little bit of skepticism, because for one thing, in the case of an asteroid or comet impact, you could also have a much larger influx of radioactive carbon into the Earth's atmosphere, and that could bias the radiocarbon dating from that period of time. So I think that we're still going to have to spend a fair amount of time trying to work out the specifics on these dates of these transitions. I'm not convinced that the first meltwater spike, which is called meltwater spike 1A, actually did occur at 14,600 years ago. But again, we don't know for sure. Maybe it did. It's just that we need to be careful about the dating of these transitionary episodes. So anyways, there were two very large meltwater spikes into the global ocean that sort of bracketed the Younger Dryas cold spell. And it was during this roughly 1,300 years of the Younger Dryas cold spell that we see the disappearance of the Clovis culture in North America and the collapse of the great megafaunal species. Now, did all the megafauna die at once? No, they probably did not. But here's the thing. We may be looking at an event that really was a period, we may be looking at a time where it can best be described as a period of clustered bombardment, not just a single episode. So that may be a false explanation. That may be actually a sort of a straw man argument that the skeptics are making by saying, well, we know that the megafauna actually disappeared over a couple of thousand years. Well, the point is that if humans did not hunt the megafauna to extinction, which I certainly don't think they did, then what did cause the extinction, right? So I think the evidence that we're accruing and accumulating at this time is going to show that there was actually a period there of maybe 2,000 years where the Earth was subjected to multiple episodes of bombardment. And the way you would explain that is by Earth running into a stream of debris from a large disintegrating comet, and this perhaps happening on multiple occasions. Just like, each year Earth now runs through the streams of disintegrating comets, right? But usually the material that the Earth is transecting, the band of material, is very small, fine material, and it's this material that basically makes the famous meteor streams like the Leonids or the Taurids or the Geminids or the Aquarids or some of the famous meteor streams that you can go out and see. You have the Leonids, which occur around in late November. You have the Geminids that occur, or you have the Taurids. The most likely candidate for a progenitor comet that could have broken up and spawned a stream of debris would have been the precursor to what is now Comet Encke and the Taurid meteor stream.
Yeah, I got a couple.
Based upon the yeah, go ahead.
I got a couple questions. What did you say the peak of the ice age was? Like the coldest part, was it 30,000 years ago? You said, or 20?
No, about 18 to 20.
18 to 20. Yeah, ago. Yeah. Okay, that's interesting. And then I have a question go ahead.
Okay, that is the late glacial maximum.
Yeah.
So my final thought in regards to the previous question was that, I think it's entirely plausible that there could have been multiple strikes on the Earth during this period of hypothesized bombardment. So an impact into the Pacific Ocean, it could have yielded large-scale tsunamis, certainly, yeah. And I'd be very interested in seeing what kind of evidence that this individual has accumulated.
Well, that Göbekli Tepe number 43 shows that it seems to show.
Yeah, I'm going to have to go back. I haven't seen that, so I'm going to have to go back and check that out. If that is in fact the case, that's very, very interesting.
And I mean, it could be it could be up to interpretation as well. It's fairly simple, those carvings on not the carvings in the stone, but the what do you call it, embossed or not embossed, but they're the opposite, right?
Engraved.
Or they're not engraved, but they're out.
Relief
carvings. So that I wonder if that was where the people of that time made it through or missed that first cataclysm, that 1300, that breaking after the 1300 years, and then started warning about it before it happened again or something like that, like the secondary one. Like I wonder if there was that middle time between catastrophes where all this kind of happened. I don't know.
I would not dismiss that idea. Again, until more further excavations are done at Göbekli Tepe, we don't really know how old it is. I think the dates are coming in right at meltwater pulse 1b, I think 11,600 to 12,000 years, right in there.
Yeah.
But they may be much older. I don't know. Maybe Graham Hancock has some more additional information on that.
Do you know of any maps that were made where before that flooding, like before the meltwater, whereas you could see, like, is there anybody that's sort of done a virtual map?
No, I don't think anybody's done anything like that. You mean done in ancient times or in
no,
modern
like
times?
In modern times, showing where the old land would have been, like 300 feet or whatever the increase is. I mean, I'd love to see where that new coastline.
You've seen there there are some maps that have been done that show the global coastline. I think at a lowered, the ones I've got in my slideshow, I think it's 300 feet lower.
Yeah.
But at the late glacial maximum, sea levels were closer to 400 feet lower. So I haven't seen anything that is down at that 400 foot below sea level. But yeah, it would be a very valuable and interesting project to assume a 400-foot lowered sea level and map the global coastline.
Yeah,
Because
like Central America. What's Central America look like? I mean,
well, it would have been much larger.
Yeah.
And
Yeah.
every island on Earth would have been much more extensive.
Yeah.
And here where I live in Georgia, we'll go out to the coast, to the seashore quite frequently. But if we weren't back 15, 16, 17,000 years ago during the late glacial maximum, if we were standing where we are now standing on the seashore, we'd have been in the middle of a forest, and it would have been another 30, 40, 50, 60 miles further east that we would have had to have traveled over what is now drowned coastal shelf to get to the shoreline, to get to the coast at that time.
Yeah, that's fascinating. So I have a question here from Rob. He emailed this because he knew you were coming on the show, and I don't really know exactly how to ask it, but we might have talked about this a little bit last time as well, but I forgot to watch the YouTube video. But we had a guy on, Ben Davidson from Suspicious Observer. He's got a YouTube channel. He takes measurements of the solar activity all the time. It's a super interesting channel, but it also has to do with the electric universe theory. So he's wondering if you've like you and Hancock will put forward this the theory of the asteroid impact like around 12,000 years ago, but could the impact that ended the last ice age be in fact a discharge from the sun? Like there's a theory that the sun is a micronova, and he wonders if you have any thoughts on that theory. I guess it would also be I think he was talking before in a different way about it being an electromagnetic discharge or something, as opposed to just a physical comment.
Well, this is okay. I can't say at this point that I'm knowledgeable about the electric universe theory, only because up to this point, the evidence that I've been looking at has not demanded that as an explanation. I'm not saying that isn't an explanation. I'm going to lead towards it was a celestial object, either asteroidal or cometary in nature, simply because of the nature of the proxy evidence is consistent with what we know. I mean, we know there's a platinum spike. There's an iridium spike. There are magnetic brains, microspherules. Every one of these things is known to be consistent with an actual impact event.
Right.
Now, Robert Schoch, his hypothesized that yes, it was it was a massive coronal CME or coronal mass ejection that caused it. Now, one of the things I've gotten really interested in is I guess you'd say it's sort of the dynamic solar system model. And the idea there is that the solar system is an interactive machine, if you will. And even small things that happen in one part of the machine can have large-scale effects throughout the course of the whole solar system. And so one of the things that I've really gotten interested in is over the last 20 years with the deployment of solar observing satellites, one of the discoveries that kind of came unexpectedly out of the blue was the number of sun-grazing comets that were discovered. Huge numbers, far in excess of what anybody had even imagined had existed. And many of these comets are seen to fall into the sun. And interestingly, even though the comets are minuscule relative to the mass of the sun, they seem to trigger effects that are completely out of proportion to the scaling between these sun-grazing comets and the sun itself. Of course, what's happening is they're accelerating to such high rates of speed as they're falling into the sun that they plunge deep through the solar chromosphere. And one of the things that has been observed and witnessed now in the aftermath of a cometary impact into the sun is large-scale upwelling of plasma vorticular plasma that will oftentimes burst out in the form of coronal mass ejection. Now, that to me could perhaps provide a link between two great realms of phenomena here. On the one hand, we've got impacts of asteroids and cometary or cometary material affecting the Earth. On the other hand, variability, a variable sun affecting the Earth, and the idea of solar storms. I mean, we know that a solar storm that could happen again, like that would be similar to the Carrington event that happened back in the 19th century. If it happens now, we're in trouble because it could fry most of the electrical circuitry on Earth, or at least on the side of the Earth that is facing into the solar storm. And that could cause major economic consequences. I mean, you know, if imagine that the whole communications grid suddenly goes down and it takes a month to rebuild the thing. I mean, that could be pretty devastating, and that would be just a very minor. I mean, I'm thinking within the scale of potential phenomena, the Carrington event was probably relatively minor. But what I'm getting back to is if there was a period of enhanced influx into the solar system somewhere, you know, tens of millennia ago. And here's one of the models. This is the British neocatastrophist Victor Klube, William Napier. I think there's an Australian astronomer, Duncan Steele. There's about a half a dozen of these guys that have been studying comets and their behavior and their interaction with the Earth. They're the ones who pretty much came up with the scenario, and it's supported by like 30 years of accumulating evidence that perhaps between 20 and 30,000 years ago, a very large comet came into the inner solar system from the cometary, the theoretical cometary reservoir of the Kuiper disk, because comets that would be engendered from that domain would tend to be, their orbits would follow close to the plane of the ecliptic, whereas if they're not coming from there, if they're coming from deep space or coming from the hypothetical Oort cloud, they could come in at all angles to the Earth's orbital plane around the Earth. But if they're coming from the Kuiper disk, or the Kuiper belt as it's called, they would be coming in on a pathway that would carry them low, so their angle of inclination to the Earth's orbital plane or plane of the ecliptic would be low. So therefore, when it starts breaking up, that debris gets strewn throughout in a belt of debris that could intersect, rather I should say, Earth's orbit. So picture a very large comet coming in, and we're talking about a cometary nucleus that might be 50 to 100 miles in diameter. It begins to break up, and it begins to spawn several meteor streams and several actually smaller comets and asteroidal-type bodies that are now in this orbit around the sun. Now, as these objects are orbiting the sun, they might get swept up by Jupiter, something along the lines of what we witnessed in 1994 with the consumption of Shoemaker-Levy 9 by Jupiter in the second week of July 1994, when we were actually able to see a comet, a single cometary nucleus breaking up and forming 21 offspring that now formed a cosmic chain that circled around the sun and looped back and plunged into the Jovian atmosphere over a period of about a week. So picture, if you will, a large cometary nucleus coming in and beginning to undergo a hierarchy of fragmentations. Now, a cometary nucleus tends to be a very loosely bound aggregation of material. So when it's out in deep space, and it's essentially in hibernation, it's in deep freeze. But once it comes into the inner solar system, it begins to come back to life, and it begins to discharge volatiles and undergo lots of stresses that can cause that nucleus to begin to disintegrate or disaggregate. So as it goes through this hierarchy of disintegrations, what it's doing is it's creating clusters of debris in its orbit. So if the Earth is crossing that orbit during a period when the concentration of this fragmented debris is greater, then there will be a greater probability of the Earth actually sweeping some of this stuff up and having a series of impacts. If it goes through across the stream when the material is widely scattered or dispersed, we probably can get across the stream with nothing more than an impressive meteor shower. So it all depends. See, over a period of time, what will happen is that debris will slowly spread out and become uniformly distributed about the orbital pathway. But before it does that, there would be numerous potential periods of time where the Earth could sweep through that debris and get bombarded, not just once. See, the Earth crosses the torrid stream twice each year, coming and going, basically, where the material is coming in, and which is actually the fall time, late October, early November. That's why the torrid meteors are quite often called the Halloween meteors. And I've got several video clips talking extensively about this up there on the Geocosmic Rex YouTube site. So if somebody wants to learn more about the Halloween meteors, they can go on that site and watch those videos. Then this stream arcs around the sun as it's coming back from the sun. The Earth crosses the stream for the second time, and this is in late June, early July, right? So the thing is that when the Earth crosses that stream during the late fall, you're looking up the stream. So you're looking out into space, and the area, the radiant of that stream, which is the point at which the stream appears to be emanating from space, not that it's actually coming from there, but the radiant of any given meteor shower or meteor stream is named after the constellation in the sky which it appears to be emanating from. So the torrid meteor shower is named after the constellation of Taurus, because if you go out in the fall, late October, early November, and you look towards the constellation of Taurus, you will see those meteors appearing to emanate literally from the shoulder of the bull, right in the area of the Pleiades, right? Which I believe strongly is one of the reasons why the Pleiades were always held in such high regard and were objects of such astute interest by ancient peoples all over the world. But in any case, crossing during the fall, the late October, you're looking up the stream, you're looking out into space, you're looking towards the constellation of Taurus. Crossing in the summertime, the stream is coming from behind or around the sun. So what happens is that the meteors tend to be visible in the fall and invisible in the summer, because you're looking in the direction of the sun, and it's coming in at you in daylight. Now, interestingly, the peak of the summertime torrids, like I said, is late June, early July. The Tunguska bolide event, 1908, was June 30th. And according to all of the eyewitness accounts that have been collected and organized together, it would suggest that a lot of the people who witnessed it said things like, it looked as if this great fireball was disgorged from the sun. It came out of the sun. You know, many of the eyewitness accounts describe such a thing. So what that's suggesting is two things. The timing of the year was appropriate to be a torrid meteor, and the direction that it came from in space was consistent with it being a torrid meteor. So I'm inclined, of all the various explanations, to believe that Tunguska event of 1908 was probably a remnant of this great stream that Earth would have swept through several times back at the end of the last ice age. Now, the British neocatastrophist guys, like I said, they were theorizing that maybe this great comet came into the inner solar system sometime around 20 to 30,000 years ago. Now, there is a possible mechanism whereby comets could be dislodged from their hypothetical reservoir in space to where they could then plunge towards the sun. And that degree of influence would be on a galactic level. Or perhaps it could be something like, Paul Laviolette theorizes that there is a galactic core explosion that happens periodically. I don't know if that's true or not. It's an interesting idea. Another possibility is a nearby supernova, something that would cause on a more galactic or cosmic level, a disruption of the cometary reservoirs that could then send possibly even multiple cometary nuclei cascading towards the sun, and in the process disintegrating and creating this litter of cosmic litter in the inner solar system that the Earth could encounter. Now, the other thing is, getting back to the idea of the sun-grazing comets, you see, if you have a very large comet that comes in, what we've seen is that there is a disproportional response in the sun to very small comets, one that might be 5 or 10 miles maximum. They say perhaps some of the sun-grazing comets that have been witnessed are about the size of the comet Halley nucleus, which is about 10 miles in diameter, right? Well, if you had, say, a cometary nucleus that's 50 to 100 miles in diameter falling into the sun, what could possibly, we don't know, but yeah. I think it would be legitimate to theorize that there could be a very substantial solar response to that, right? So in that scenario, it's very possible that we could see how we could synthesize these various phenomena, and actually it then maybe to say, well, yes, perhaps if the solar system was subjected to this massive influx of cometary material, it's going to affect not only the Earth, we might even be looking for effects on Mars. We might be looking for effects on the Moon, right? But it also might be looking at a response from the sun itself, you see. So it could be that we have to expand our thinking to a much greater phenomena than just one dumb rock hitting the Earth. And to say, well, if in that model, that's oversimplified model, then yeah, then it should be, there should have been one mortality event. It should have been global in extent, and because obviously when you talk about some of the species of woolly mammoths, or mammoths, for example, it's estimated there might have been 10 to 12 mammoths worldwide during the late Pleistocene, right?
Million.
And they were distributed from all the way across Eurasia, across the Bering Land Bridge into Alaska. They ranged in the unglaciated southern United States. They were in Central America. Mastodons were in southern United States. They were Central America. They were South America. Yet they went extinct over the entire globe. And it wouldn't have taken many at all. I mean, think about American bison. There were millions of bison roaming the Great Plains, when the Europeans arrived, maybe, in 1800, 1850, in that period in there, right? Around the turn of the 20th century, the numbers of bison had been reduced to just a couple of hundred individuals. But now that particular species has rebounded to the extent that you can go into any grocery store and buy a bison burger, right? So if you were looking back 10,000 years from now, you could completely miss the fact that the American bison came within a hair's breadth of extinction, right? So what I'm getting at, though, is that if you have to exterminate, you see, you can't even have a single mating pair survive, or at least, even a half a dozen or a dozen mating pairs, because that is enough to reestablish a species. You have to kill every single individual of the species, or the species will survive and it will procreate and replenish the species. But in the case of over 100 species of mammal at the end of the last ice age, they did not survive. Now, it's one thing to say, well, Paleo-Indian hunters in a blitzkrieg assault wiped out the mammoths worldwide. I've gone in the research that I've been looking at, trying to get a handle on, well, how many people occupied the Earth at the end of the last ice age? Most of the estimates that I've come across in the literature and in the various studies suggest 5 to 10 million people was all, right? If that's true, then you're talking about there were more mammoths in the world than there were people, right? So, but the thing is, you could have a group of people go into one particular locale or one particular region and wipe out all of the animals that were in that region. But you have to simultaneously wipe them out over the entire planet, or they ain't going extinct. Sorry. And the thing is that, when you begin to look at the lifeways of the ancient cultures, like the Clovis, who who have taken the blame for the extermination of the late Pleistocene megafauna, they were considered to have, the term is overkill. They were such voracious killers that they were able to sweep across the Bering Land Bridge, down through the ice-free corridor, all the way to the Tierra del Fuego, and in the process wipe out 10 million mammoths, along with 90 or 100 other species, including the great cave bear, the short-faced bear, the Irish elk, the giant camels, the glyptodons, the mylodons, the giant beavers, on and on and on and on and on. But they all went extinct. You see, that's the point. And, you can't tell me, okay, human hunters killed the mammoths. Well, what about the American Pleistocene lion? Well, what about the saber-toothed cats? They went extinct. What about the great, the Pleistocene cheetah? That went extinct. What about the woolly rhinoceros? They went extinct. You see, are you going to say then that these Paleo-Indian hunters on foot carrying spears was able to exterminate all of those animals? Yet all it takes is a little bit of thought and a little bit of knowledge to realize that scenario is ludicrous, right? Did humans hunt woolly mammoths? I think the evidence is clear that, yeah, they did, just like modern humans, modern native tribes in Africa hunted elephants. Although, for the most part, most of them stayed away from elephants because elephants are extremely big and very, very dangerous. The one tribe of people that did hunt elephants regularly was pygmies, and their strategy was to have very sharp spears. They would run under the elephant's belly, pierce upwards with their spear, apparently in the spot where they just knew that they would have a rapid bleed out, and then they would simply follow the elephant until it succumbed to blood loss, and then they could kill it off. See, but at the same time, what we see is that the Clovis people hunted small game. They did lots of gathering of produce from natural produce. They also fished and so they had very diverse diets. And a tribe killing one mammoth for whatever reason, I mean, the amount of meat, you're going to have a couple of tons of meat.
They don't bother. They just slice
season.
off a burger, fucking leave the rest. That's
Yeah, right. The whole scenario just makes no sense, and it never has made sense. But that's been the dominant scenario since the middle of the 20th century, anyway. And that particular scenario, the Blitzkrieg, the Paleo-Indian Blitzkrieg scenario, was really beginning to lose favor as we get into the 80s and the 90s, and more information was coming to light about the actual lifestyles of the people of those times, the Clovis people and so on. And it just was not consistent with a group of people that would be on this rampage, killing everything in sight and leaving this, like the killing fields of Pol Pot or the killing fields of World War I, where there were so many bodies that they just laid there, I mean, so really, you almost of necessity have to turn to the idea of some type of a catastrophe. You can't get around it. Now, where we're at is nobody really has the final explanation yet. I think, like what I'm getting at, is that we might be looking at a kind of a perfect storm, multiple phenomena interacting, amplifying each other. Just like I was using the analogy of the year without a summer being associated with two things. It was a period of low solar activity, which would produce a natural cooling, along with heightened volcanic activity, would also produce cooling of the Earth. So those two things together, created a couple of years where 1816 was the worst. For most of the Northern Hemisphere, they call it the year without a summer. In New England, on July 4th, there was a snowstorm, right? They were going to go out and celebrate July 4th, and people got snowed out. So, and crops died in the fields. They attempted 3 times to grow crops, and 3 times the crops were frozen out. So, and you literally had a period of like diminished sun, where people describe weeks at a time where the sun was barely visible because there was so much particulate matter in the atmosphere. Now, this is from a volcanic eruption, Mount Tambora, which erupted in 1815, the year before. And it took 3 to 4 years for that particulate matter to clear out. But the thing is, some of the consequences of that they're looking back now and thinking that perhaps lasted literally for decades, far longer than anybody had previously imagined. Because basically what it did was it injected this degree of chaos into the system, and even though the most immediate apparent effects ameliorated within 3 to 4 years, the after effects continued on for several decades. And I could certainly see something like that on a larger scale occurring at the end of the last ice age. So, if you had impacts into the ice sheet, if you had impacts into land, if you had impacts into the ocean, each one of those impacts is going to produce a different suite of effects.
Yeah.
Right? Yeah, in some cases, like if the strike is strictly on land, it's going to inject huge amounts of particulate matter into the atmosphere, right? That's going to create a canopy that reduces solar radiation. It's also going to produce extensive wildfires, which put soot and smoke into the atmosphere. So an impact into land exclusively would have a tendency to cool the Earth. If it was into the ocean, what it's going to do is it's going to loft huge amounts of water vapor into the atmosphere, which is really the most effective of all the greenhouse gases, and it could cause a heating. What would happen if you had multiple impacts where you were both into the ocean and or into the land or even onto an ice sheet? Well, here I think the consequences would be so chaotic, it might take decades, if not centuries, for these phenomena, these secondary and tertiary phenomena to play out. And then maybe even by the time they played out, you might have another round of bombardment, you see. It's such our infancy of understanding these great forces that have played out over the surface of the Earth and in the solar system as a whole. We just have a whole lot to learn yet about how dynamic, truly dynamic, this planet is that we inhabit. That's why, Graham, it really irks me when I hear somebody saying that the science on climate change is settled. That the debate is over. It's so far from being settled that it's just, it's a completely absurd statement to make that and to believe that.
Yeah.
And then say, okay, now we're going to enact policies based upon this assumption that the debate is over and that the dominant influence on climate is now anthropogenic.
Yeah.
And we can disregard all of these other potential forces that have played out over the Earth and the climate on any time scale that we can measure.
Yeah, exactly.
Right?
Yeah.
We're just going to ignore all that because if it's the sun that's causing the warming, and I'll tell you right here and now, I think that the most of the warming of the 20th century is solar related rather than carbon dioxide related, and there's tons of megatons of evidence to support that. Interestingly, that evidence gets ignored.
Yeah.
The IPCC chooses to discount the sun. They say, well, it's the solar constant. So based on the solar constant, we can disregard the sun, right? No, I'm sorry. Every bit of evidence is now pointing to the fact that the sun is a much more variable star than anybody had imagined 30 or 40 or 50 years ago. And we're just beginning. We've only got 10 to 20 years now of satellite observations of the sun, and what we're seeing is that it's filled with, it's all kinds of things that were discovered, like that I mentioned, the sun-grazing comets. Nobody knew about that 30 years ago, right? That there were sun-grazing comets, every few weeks a comet falling into the sun, and then the sun having a hyperactive response to that, you see? So, and again, think about in the last couple of decades, how many times have we seen cosmic debris flying past the Earth, flying within the zone of the moon? Every few weeks, every few months, it's gotten to the point now where it's almost passé. There's going to be another, half-mile asteroid passing, just outside the orbit of the moon? Yawn. Well, look, what that's telling us is that the inner solar system, our cosmic neighborhood, is a hell of a lot more densely populated than anybody was imagining a generation or two ago. And interestingly, as astronomers are looking out into the cosmic neighborhood and seeing that there's a whole lot more stuff out there than anybody had imagined, and it's flying by the Earth all the time, while they're looking up at the sky, geologists have been looking down at the Earth and discovering that there are hundreds of that the Earth is scarred by multiple impacts all throughout the history of this planet. That has been one of the recurring episodes in the Earth history, is bombardment from space. And it's now being correlated with everything from climate change to geomagnetic field change to mass extinctions, all of these things. So what is happening, and my point that I'm trying to get here, is that, yeah, we are just really on the threshold of a whole new model of how the Earth works. And in order to understand that model, we have to really be literally looking at the entire solar system and looking at all of the factors, not just exclusively saying, well, it's only carbon dioxide. Because for one thing, carbon dioxide is limited in its function as a greenhouse gas. It's only good up to, what happens is carbon dioxide captures most of its heat. Most of the heat that's captured by carbon dioxide is in the first 50 parts per million. And each increment, say 50 parts per million increase after that, it has an exponentially diminishing amount of heat that it can capture. The IPCC scientists, they know this. So what they have to do is they have to introduce positive feedbacks into their models in the form of water vapor. So what they do is they say, well, this increase of warmth caused by the carbon dioxide is going to cause more water vapor into the atmosphere. More water vapor is going to trap more heat. That's going to warm the oceans. Then the oceans is going to outgas more carbon dioxide. But what they're not accounting for, and there's a whole lot of evidence to support the idea that there's a net cooling, because water vapor will form clouds, and clouds generally reflect radiation back into space, depending on the type of cloud. Some clouds allow the radiation through, but others reflect more into space. The consensus of opinion that's emerging now is that it is a net cooling caused by cloud formation. But again, it's something we're just beginning to understand, you see, and the fact that Earth's climate and atmosphere can respond dynamically to changes in the Earth's geomagnetic field, and the Earth's geomagnetic field can respond in turn to changes in the solar activity. You see, so like I'm saying, my point is we're having to really understand now that Earth is part of a much bigger dynamic system that involves, yes, the whole solar system, but probably even beyond. We have to look at the whole nearby stellar neighborhood. Like I mentioned earlier, the idea that nearby supernovas could cause an influx of cometary objects. And none of this is known for sure. I'm not saying this is the way it is, this is the way it is, this is the way it is. What I'm saying, though, is that there's a lot of evidence to suggest these as very real possibilities. And we know that it has to be more than carbon dioxide. Of that, there can be no question. Anybody who looks at it has to realize, it's definitely more than carbon dioxide. Because for most of Earth's history, what you see is carbon dioxide levels in the Earth's atmosphere have been 3, 4, 5, up to 10 times greater than at present. And what we see is that the very low carbon dioxide levels in Earth's atmosphere coincide with the onset of the late Quaternary glacial cycles. Precisely, right? What happens if there's a natural cooling, let's say the sun goes into a period of inactivity, then there's a lag time, there's a lag response where the oceans will begin to cool. Right now, if the oceans cool, it changes the solubility of carbon dioxide. So it lowers the solubility, so carbon dioxide is outgassed. Is absorbed. When the oceans warm, carbon dioxide is outgassed. So you have this almost like the oceans breathing in and out of carbon dioxide, and that's going to be affected by changes in the amount of solar radiation. See? So it's a fair question to ask, well, when we look at increasing concentrations of carbon dioxide in the atmosphere, undoubtedly our consumption of fossil fuels is contributing to that. But also, almost just as certainly, the active sun that has now been overwhelmingly documented to have occurred throughout the 20th century would have caused an oceanic warming the ocean's response to that would be to outgas CO2. So what component in the atmosphere is oceanic outgassing? What is fossil fuel burning? We don't know, for example. We don't know precisely what that cutoff is. But we do know that if nature was not constantly replenishing carbon dioxide, it would quickly be sequestered into the oceans and turned into the limestone rock that forms the huge reservoir of carbon dioxide in Earth, you see. And what happens is, if the sun cools and the oceans cool, the oceans start sucking out the atmospheric carbon dioxide, right? Pre-industrial concentrations of carbon dioxide about 280 parts per million. Present concentrations about 400 parts per million. Now, even 400 parts per million is very low compared to most of Earth history, right? But what happens when you get down to ice age concentrations are down, actually looks like they could have dipped below 200 parts per million. Well, that's a dangerous threshold, because below 200 parts per million, plant photosynthesis begins to shut down.
Jesus.
Right?
Yeah, I think the founder of Greenpeace said 180, everything dies. At 180, that's it. That's the
we were within 10 to 20 parts per million of that during the depth of the ice age. To me, ramping the CO2 back up to 400, 500, or 600 parts per million really might be very beneficial. And of course, you can also see that all the projections. If you look at the old projections from the 60s and 70s, based upon projected forest inventories and inventories of plants in the biosphere, they were all way, way too low, because nobody was taking account of the carbon dioxide fertilization effect. And so now we've got evidence that the Earth is literally greening, and that is being driven by the fact that the carbon dioxide concentrations in the atmosphere have gone up and stimulated plant growth worldwide. It's for the same reason that commercial greenhouse growers will pump up the carbon dioxide to 1,000 to 1,200 parts per million, because plants love it. Plants flourish under increased carbon dioxide, and they wilt and wither under diminished carbon dioxide. So, I think my opinion is that, we're looking at things like, and I'll go ahead and bring it up, because if we take this assumption that the science is settled, that debate is over, we know what's causing quote-unquote climate change, right? You take that to its logical extension, what you end up with is basically the Green New Deal. This fantasy that, the world is going to end in 12 years unless we have this radical transformation of the global economy and shut down the use of fossil fuels. We probably shouldn't get into talking about that tonight.
Yeah, we could probably save that for May, when we've got like hours upon hours to just chat about all this stuff. I mean, it would be fantastic sitting at the cabin, the campfire, talking about the Green New Deal and how it's just a big sham. But I mean, I did have a conversation with a friend of mine the other day about the commentary thing, and I don't know where he got this from and how mainstream it is, but he acted like all of them have been spotted and are measured, like there's no risk. And I'm like, what?
Yeah, we know where they all are. It's all good.
Yeah.
We got to figure it out.
No, I don't know where he got that from. I don't. I can't.
Yeah, okay. I thought so. Yeah, it's totally false, right? I mean, we don't know. I mean, we're just finding a lot of this stuff out now, right? Yeah.
Well, you could say this. You could say, for example, if we're going to look into if we're going to try to get a census of, say, 2-mile asteroids that could potentially collide with the Earth in the next 100 years, say.
Yeah.
Yeah, we've got a pretty good idea that, we've got those all counted. But the problem is that imagine that you've got a cluster of 10 or 100 Tunguska-sized objects.
What was that again?
Well, okay, so like the Tunguska object of 1908, it was about 150 feet in diameter.
Oh,
we have no idea how much of that stuff is out there. Now imagine not just a single Tunguska, but in the neocatastrophist models, you may have a bombardment episode where you have anywhere from a few dozen to a few hundred Tunguska-type encounters, right?
Grams.
Now, that's really, the danger from the big things, like, say, something equivalent to what took out the dinosaurs for our immediate future is minuscule. And if there was a 6-mile diameter asteroid orbiting the sun out there, making a solar Jovian orbit, we would know it. Yeah, absolutely we would. You get down to below 1,000 feet, say anywhere between 100 and 1,000 feet, yeah, there could be all kinds of stuff out there. We have no idea. And in fact, it could be that there are kilometer-sized objects still in the torrid stream that we haven't discovered yet.
Yeah. That's a good point.
So, I mean, I don't know what your friend was referring to.
No, that's a good point, though. I mean, it is a good way to separate it. They're still very destructive at a mile or less in diameter. Yeah.
I hadn't considered those those meteor showers. Go ahead, Randall.
The Tunguska object. What's that?
Go ahead.
Well, I was going to say the Tunguska object, when it exploded. It was an atmospheric explosion about 5 miles up from the surface of the Earth, right? It exploded with a force about equal to 15 million tons of TNT, which is about the same size as the biggest hydrogen bombs in the American arsenal at the height of the Cold War back in the 60s and early 70s, right? 15 megatons. The biggest Tsar Bomba, which was the largest Soviet hydrogen bomb ever tested, that came out at about 55 megatons, right? But basically, a hydrogen bomb of 15 megatons would annihilate any metropolitan area on Earth, right? Tunguska happened over old-growth taiga forest in northern Siberia in a very sparsely populated area, right? And it was for this reason it was almost 2 decades before any scientific observers were actually able to get to the site and, begin first-hand field studies, right? Imagine if you had a Tunguska today that happened over the east coast of the United States, over the west coast of the United States, or over the Great Lakes region. You would have literally millions of casualties, right, just from that one. Now, in the models of the British neocatastrophist, you might have bombardment episodes where you would have multiple Tunguska-like objects at one time, you see. Now imagine, then what we're talking about could almost be likened to a thermonuclear war, minus the radiation, of course.
Yeah.
But so to say that, we've mapped everything and we know, no, that's just not the case. He must have some other agenda that he was...
Well, or he might have just been he might have been hearing a talking point about larger ones, that we've identified all the large ones. So your point is still very valid. Yeah.
So do you think
if he's talking about things like the Cretaceous Tertiary event that left the big crater in the Yucatan and largely contributed to the extinction of the dinosaurs, yes, then I would agree with him.
Yeah, okay.
So can we look at all those meteor showers as being like the remnants of catastrophe? Because the next time I watch the torrid, I'll probably be thinking a little different. And can you watch all the meteor showers and think, hey, it's like one of those the remnants of the dinosaur killer? And
No. Something from 65 million years ago, we wouldn't find any trace of that left. They would have been long ago swept up by the sun or the planets, or just disintegrated into dust. The things that we're looking at are probably all going to be from a few thousand years to a few tens of thousands of years ago. They wouldn't be that old. I'm not sure what the torrid meteor shower is actually considered to be one of the oldest, simply because it's a very diffuse meteor stream. The Geminids, Earth will cross the Geminids in a couple of days. A day, it's crossed the peak of the stream. The torrids take 10 to 12 days to fully cross. The stream has had more time to become diffused, which is a function of how many times it's orbited the sun. So the torrid stream is most likely one of the older meteor streams, and it's estimated to have been produced by a comet that would have come in, like I said, 20 to 30,000 years ago. And I might add there that maybe it's very possible that what's called the late Wisconsin phase of the Great Ice Age, which was preceded by a 10,000-year period of considerably warmer climate that interrupted the longer ice age of 100,000 years, that came to a sudden end around 26,000 years ago, with sudden cooling and re-expansion of the North American glaciers and the Northern European glaciers. I think it highly possible that that may have been a function of the influx of cosmic material associated with the progenitor comet, because the comet comes, let's say if the comet comes into the inner solar system roughly 26 or 27,000 years ago and begins to discharge large amounts of cosmic dust, and then the Earth is regularly sweeping through that dust as it orbits the sun, you could have a protracted period of global cooling. And that's kind of exactly what we did see around 25 to 26,000 years ago.
Interesting. All right. Well, before we run out of too much time, we should. Do you want to? Can we get back into the trip at all and talk about more
so
things?
this is like we'll dive into this stuff down over the trip. Yeah, we can. So I think we're gonna split it up. So we'll do. We're gonna have the buses there. We're gonna have a couple. Well, not buses, or vans, big vans. We'll have a couple of vans rented.
Yep.
We'll have breakfast. We got a catered event. We got friends of the show, Keith and Gage, gonna help out with catering. And we got a giant estate cabin on 122 acres in Pagosa Springs. We're going to be hanging out there. We're going to set up a space where Randall can do some lectures and some slideshow presentations as he sees fit over the course of the 3 weekends. So we're splitting up into 3 groups of 25.
2 weekends in the week between.
Yeah. So there's May 17th to 20th, May 17th to 20th. Here, I got it.
Yeah, May 17th to 20th, and then the 20th really again to the 23rd, and then the 23rd to the 27th.
Yeah, that's right. So we got a big giant house rented, 10 bedrooms. All the information's on the website. So anyway, basically, Graham and I will be down there in one of those bedrooms, and Randall Carlson will be there in a room, and we're going to be doing some presentations and some field trips to Mesa Verde and Chimney Rock and who knows where else. We're finalizing the itinerary here over the next couple of days, and we'll post all that.
We'll do some good eating. We may take a historic train ride. We may go soak in the sacred springs. I'm going to, I'm a percussionist from way back, so I'm going to be bringing some percussion instruments, and we can have some, maybe a couple of late night around the bonfire wild drumming sessions, just to raise the spirits of the dead.
Absolutely. I might just eat a bunch of edibles and then wander off.
Listen, man,
actually, for people that are coming, if they have instruments, I'll be bringing a singing bowl probably, because I want to go out and do some sky watching and look for some UFOs and stuff out there. Maybe take a couple groups out for a little CE5 action. Maybe
a guitar out there.
And then we're close to like other stuff, like the Four Corners is only 2 hours away.
Well, I think actually Graham Hancock's doing an event not too far, only like a 6-hour drive away on the 16th, right before we kick that off. So if anyone wants to try, I think it's in Sedona, which is a little ways away. But I mean, if someone's flying into the area from a little ways away and they want to sneak in some Graham Hancock before going to hang out with Randall Carlson for a couple of days, I mean, that might be a good reason to go to that first weekend, the 17th to 20th, because you could turn that into a Graham Hancock drive for a day, hang out with Randall Carlson and Grimerica for a couple of days. Graham will probably call some UFOs over.
That's the plan. I mean, it's a ways away from Sedona's a ways away from Pagosa Springs for sure, but I'm sure it would be a nice drive there.
Wonderful drive. Yeah.
And then Dulcie's close by too.
I should mention. Well, go ahead. If
no,
you're about to say something that I will mention.
No, okay. Well, I was just thinking Dulcie's also close by, which is probably an interesting place in the San Luis Valley. So there's a lot of interesting things to do around there.
Yeah, there's no shortage of interesting sites, geological, archaeological. I don't know about any paleontological sites that would be within easy access of there. But yeah, we would certainly have enough. What I was going to say is I am reading the pre-publication. Graham Hancock sent me his book that's coming out in America in April. That's why he's going to be down in Sedona during that time. He's doing his book tour. But his book, America Before, I'm reading it right now. Man, it's an intense read, and some of the stuff that he has uncovered and putting in there is really phenomenal. So yeah, that book will be coming out in April. So I I'm about not quite halfway into it. It's Graham writes these massive tomes. This one has 578 pages, extensively footnoted and referenced. But I won't get into the details of what he's getting into so far, but it's very important stuff, and it's definitely paradigm changing.
Nice.
And we'll be talking about that.
Stuff. Yeah, we'll definitely be talking about that, because by that time, the book will have become available, and maybe there will be people there who've actually read it and brought it. Highly recommended. Yes, it's definitely, it builds upon his earlier work. It confirms what I've been doing, the idea of periodic catastrophes and the rise and fall of civilizations and the unknown story of what transpired in both North and South America in prehistoric times. And it is really phenomenal, I got to say. What's being revealed with LIDAR to have occurred in the Amazonian jungles, for example, is almost like something out of science fiction, but it's totally real.
That's awesome.
Yeah, I can't wait for that. It's going to be a great trip. Like I say, it'll be intimate, it'll be interactive. We'll be able to speculate a little bit off the record, and it's going to be a fun time.
Yeah.
People are going to be sorry they missed it if they missed this one. I'm telling you, it's going to be great. We got some people in the chats asking about the moon. Maybe we'll save the moon for the trip.
Oh, yeah.
We'll be able to talk about the moon and all that great stuff. I'm telling you, May 17th, 20th, there's those three things. Check out badcomet.com and get on board.
We've had a couple of these meetups for the last couple of years where we just meet a bunch of friends of the show and we chat for a weekend. And I mean, it's fantastic just chatting and with like-minded people, and it's really, that's part of the whole attraction for me to this whole thing. It's just fantastic.
A big part.
Yeah.
Yes, and I think that's going to be one of the really valuable things that come out of this is there's a whole tribe of us people that are very interested in these bigger questions and doing the research and sharing our knowledge and connecting with people that are really awakened to these possibilities and what it might mean for our own future by reconnecting with our past. But what I'm getting at is the networking that can transpire in events like this is extremely valuable.
Yeah. That's right.
Well, I mean, hey, that's how we made this friendship, right? You happened to come through Canada and we hung out for a couple days, and here we are 3-4 years later putting on events together. Yeah. So, the things that can spur out of something like this are endless.
Yeah, absolutely, yes. And I think, then there's plenty of reasons to be talking about this because, all of these things that we're learning about our past, these revolutionary things that we're learning about our past, have tremendous implications for our future. And any scenarios that we concoct about what we should do and how we should plan our future on this planet that doesn't take account of these changes in our past is going to be doomed to fail.
Yeah.
So that's a big part of it. Very much so.
Yeah, definitely.
But then the idea that what we're learning from looking at our ancestors is that, yes, there was very sophisticated knowledge in ancient times, and it was very much about people knowing how to live with the earth. So, a lot of that we're beginning to discover. See, my take on it very briefly is that when we're looking at all this phenomena around the world, the megalithic phenomena, the monumental earthwork architecture, the temple building, all of these things are part of a forgotten, lost technological system. And to recover some element of that system has tremendous implications for our own future. And, exactly. And these are the kind of conversations we can be having around the campfire.
Yeah, exactly. Right on.
Yeah, so check that out. Of course, do remember that when you check out the website and you see the prices and they might look a little high, just remember that does include your lodgings in a giant estate for the event, and it does include your meals, and it does include transportation around wherever we go.
Yeah.
So yeah, and that transportation does include, if you're at the Durango airport, we'll get you. So you don't have to, if you get to Durango, you don't have to rent a car or anything. We'll pick you up. We'll get you back in time for your flight. You're only on your own for supper. And the only reason we did that is because too many stuff's going to pop up. You guys are going to, we noticed in the past that, you need some time for everyone to split up.
People take off in little groups
Yep.
and stuff like that too. And yeah, that's totally cool. Yeah.
Right.
And then the other thing I want to mention is if people aren't familiar with the depth of your work and your knowledge and your presentations and your lectures and all that, I mean, they can check out Sacred Geometry International as well. I mean, you talk about sacred geometry and heavy metals and some esoteric stuff and the cathedral building. And I mean, and the Grail. I mean, the amount of fascinating topics you cover is just mind blowing. So people can easily get more information from your website as well.
Well, yeah, I was just going to say I wanted to give a shout-out to Cameron Wiltshire at Sacred Geometry International for all the work he's been doing, and a lot of great information over on that website. And then also to Brad Young on Geocosmic Rex and all the great work that he's been doing. Between those two websites, people should be able to get a good, generous dose of all the things that I've been doing, plus a lot of other people that are doing this kind of work. So, yeah.
Excellent.
Absolutely. Yeah. Shout out to the Sacred Geometry people that are over here tonight. So, big podcast day. We have Alex Jones and Joe Rogan and Randall Carlson and Grimerica again. I think this is your 7th appearance. So, we might hit the double digits here before 2020. I like it. Yeah.
And you know what? I may end up going back on Joe's show before the May event.
Oh,
I actually reached out in the aftermath of that discovery of the subglacial crater up in Greenland a few months ago, just before Christmas.
The 11-mile one, yep.
Yeah. He reached out and wanted to know if I was ready to come back out and discuss that. And at the time, I was undergoing a series of major oral surgeries and couldn't talk too well. So I said, well, I need to finish up these surgeries. This was a whole process that took almost about 8 months to complete. So it's done now, but I had my last appointment actually last week. So everything is checking out. Everything's healed up good. But yeah, when he reached out to me, I had my mouth wired up, so I wasn't a good state for me to go out there. So it could be that I'm pretty sure Graham Hancock's going to be back on his show when he comes to town.
For the new book, yeah,
so
for
it
sure.
Could be.
Yeah.
It could be that I get back on there, and if I do, I'll certainly plug the retreat.
Awesome. Yeah, that'd be good.
Absolutely. Yeah, and send all those Roganites over to the back catalog to mine out our Randall Carlson nuggets.
Yeah.
I'll put a playlist together for them. Yeah.
Okay.
Introduction to
One
Randall
of these
Carlson.
days, I'm going to get Joe out in the field because I just knowing Joe, he needs to get out in the field and spend a week seeing this stuff for himself.
Yeah.
That sounds
really
fun. We'll start in Calgary. Yeah. We'll rent a bus and we'll do the tour. It'll be great. Like it's a great drive from here, man. You go down through.
I'm gonna drive. I think I'm gonna drive. I think I'm gonna take I'm gonna try to take a little bit extra time. I think and drive all the way down.
Will you drive people?
Check out
Will you
the
pick
site.
people up along the way?
Yeah, maybe.
If there's people that can afford a ticket but they can't afford the airfare or something like that.
Yeah, maybe we can carpool or something.
So there you go. If you're between Calgary and CAC, Pagosa Springs, and you're like, I might be able to get the money together for a ticket, but I can't afford the plane ticket. Hey, maybe Ground pick you up. You just got to get your ass over the expressway. They'll pick you up there, and it'll get weird for a couple of hours or a couple of days.
Never gets weird.
No, it's only awkward for the first 20 minutes. You guys will be fine. Anyhow, big thanks, Randall. We'll let you get back to your day, your night, and come back anytime.
Oh, yeah. Well, I'm sure I'll be talking to you guys next Monday.
We should mention that, actually. If you guys, if you do sign up and you get yourself on the guest list, we do a Monday night Zoom for all the people that are going to the event where we kind of catch up. Graham and I and Randall aren't there every Monday, but we're all there at least once or twice a month. So you pop on and you get to chat with Randall yourself and ask him about what's coming up at the event. And people have been loving that. So thanks for doing that, Randall.
Oh, good.
Yeah.
Oh, yeah.
Yeah.
And, last time was was good because for the first time, really, I actually kind of did a slideshow.
Oh, nice.
And we had some lessons in catastrophic geology.
Wow.
We start recording.
Yeah, you might have missed that, Graham.
Yeah. No, that's great.
Yeah, just kind of like a foretaste of what we'll be doing out in Pagosa Springs.
Yeah, that's fantastic.
It's once in a lifetime. Well, thank you,
All right,
Randall.
buddy.
You have yourself a great weekend, and I'll talk to you on Monday, sir.
Sounds good, guys. Have a good night.
Okay,
Talk
see
to
you, buddy.
then.
Bye-bye.
Bye.
Well,
and that was our chat with the one and only Randall. See, I'm getting better after going over and hanging out.
Yeah, every time we do that, I don't know, man. I feel like it's clearer and clearer in my head, and I learn more every time we talk to him. Some of it overlaps with our past discussions, but there's always a little bit of new information in there, new
never ceases to amaze
revelations
me.
and
Yeah, absolutely. So, of course, guys, head over to badcomet.com. I would recommend today, sooner than later. 50% gets you in the door. So, if you can just get 50% of a camp spot or something like that, we should also mention that if you do take a camp spot, you do still, you're allowed in the house.
you can also,
You're in the house the whole time.
Everybody's allowed in the house.
Tent. Everyone's allowed in the house. Everyone's allowed to use all the amenities of the house. You're just sleeping in the tent.
Yeah. Yeah, it's a big place that can hold.
I mean, if it was me, I would take a tent over a bunk room.
Really?
Yeah, I think I prefer the privacy. Scary? Yeah, well, you get scared easy.
Yeah, I don't get scared easy.
It's like we got
only when I'm by myself.
There's a private lake with a paddle boat.
Really?
Yeah.
A private lake.
Yeah.
So you can also
like
email Alan right away if you want to email Alan as well, who's organizing it.
Yeah, that's CAC 2019 at hdtravel.me. Again, that's badcomet.com, 50% down. Get it down. There's about 45 spots left right now. The third weekend's...
Ooh, that's not much, actually.
No, the third weekend's about gone. Like, the third weekend could be gone by the time this comes out. There was almost 100 people watching the live stream. By the time this comes out on Friday, another couple hundred people have watched the YouTube video. So, it's probably worth getting on board. So I think there's 3 spots left in the last weekend. 20 some spots left during the week, and same thing on the weekend. So head over there today. Badcomet.com's got pictures of the amenities and everything else. Like I say, Graham and I will be there as well, doing some other stuff. Graham will probably do some D&D. I'm trying to line up, actually I shouldn't say, but I'm trying to line up a tour of because Colorado's a legal state. Everything's legal.
Yeah, I was just going to mention.
So we're looking at maybe I'm talking to some of the local guys down there about trying to line up where maybe a few of us can head over and do a tour of a grow up where they're doing some pressing, some concentrates and all that sort of stuff.
Yeah, that's fine. And then I was just going to mention, if people want to stay sober and go out and look for UFOs, we can do like we can get high naturally by meditating in a circle, and we'll see some craft flying around out there. Maybe even get a little bit of a closer visit.
There you go. Your first ever encounter. There you go. There you have it, folks. I'm telling you, check this shit out. Also, Grimerica.ca/support because we couldn't do it without you. And like I say, we're not even quite at 1%. So if we could get 1 out of 100 of you to support the show, we'd be pretty happy about that.
Yeah.
Help us get there. That's like a little pat on the back.
No, we'll shoot for 2 of 100.
Well, let's start with 1.
I remember when we first started this percentage thing, you were like 4%. We can get 4.
I know some people are doing 10 or 11.
Yeah.
But they're doing
different model, yeah.
Different models. Hey, maybe we got to switch.
We don't want to split up our
Maybe we got to switch.
We don't want to split up our eps in half. We don't want
to do that. We love you guys. We just want you to love us back with a little support.
And check out the Black Budget. Black Budget feed's got lots of good content in it. So you do get access to the Black Budget feed. It's just not the second half of all the episodes because we want to keep all that together.
Yeah.
For now.
Rent some motherfucker. All right, guys. Grimerica.ca/support. Also Grimerica.ca/news for the newsletter. Do all the stuff in there. There's a million things to do in there. There's the chats. Grimerica.ca/chats.
Got voicemail. Leave a voicemail.
Oh, yeah.
Or you can text 403-702-6083. You can put a 1 in front of that. Also, email your stories and sightings and feedback, synchronicities, all that stuff. I mean, that's one of the best parts about doing this is involving all you guys and your stories and your feedback and all that stuff. What were you going to say?
Yeah. Graham at Grimerica.com.
Yeah.
Email them. Get it going. All right, big shout out to everyone who tuned in live.
Yeah, thanks for listening.
We're doing the intro. It's only 9:20.
Oh, I don't know. We'll see.
Okay. Anyway, we'll catch you guys later.